Okay, today is under chapter 2, fluid mechanic by Porter. Alright, so today we're going to cover the fluid static. So what is the fluid static? As it names by the statics, which mean there is no motion, it fits static, the study of fluid with no relative motion between particles. Alright. Okay, this is my pen tool. Okay, everyone, what it means by no relative motion between fluid particles. So let's say this is the fluid. Okay, this is the fluid particle, such as water. And behind, so at the bottoms of the fluid, there is a layer, the top layer. Okay, consider this is interconnected together. Okay, so that means when we consider it is fluid static, right, there is no relative motion. Relative means we refer one to each other. That means relative. Okay, this is layer 1. This is layer 2. And this is layer 3. You can see this layer. Alright. The relative means layer 1 to layer 2. No motion. That means there is no motion. Okay, between fluid particle. So because of that, no shearing stress. Okay, remember that shearing stress acting on the lateral direction. Okay, if this is no motion, definitely there is no shear stress. Shear stress is this way. This is cuboid. This is shear stress. Remember, the shear stress is acting lateral direction. Okay, this is normal direction. This is lateral direction. So, in case when we have the motion in this direction, definitely we're going to have the shear stress in opposite direction. Okay, so because there is no relative motion between two layers, that means there is no shear stress. Alright, I hope you understand about that. Okay, everyone, are you get it? What is no shear stress?
Yes, doctor.
Yes, doctor.
Okay. Okay. So only normal stress. Okay, why we have only normal stress? Can you explain why we only have the normal stress? Because of what?
Because the force is perpendicular.
Okay, force perpendicular, correct. That is the definition. I want you give why the reason we have the normal stress.
Because we have a layer of fluid particles on top of another.
Yes, correct. That is perfect. Okay. The reason why we have the normal stress is due to we have the layer by layer. Okay. Okay, this fluid particle will give the stress direct to this layer. Okay, it is normal. So that is why, because this fluid particle have the mass. Okay, when the particle has the mass, definitely will give you the force, the weight. Will give you the weight. The weight will act as the force. So the force is acting perpendicular direction. So that is why we have the normal stress. Okay. And thirdly, pressure at any point in a fluid at rest is the same direction in, the pressure at any point in a fluid at rest is the same in every direction. Okay, let's say this is the point, okay, and this is the fluid particle. Okay, the pressure acting to this particle the same. I mean the same strength. Whatever direction. For example, this is 3 Newton, 3 Newton, 3 Newton, 3 Newton. Also like this, 3 Newton. Make sure it is acting on the same point. Okay, 3 Newton. So that is what it means by in every direction. Okay. So in order to understand the pressure at the point and how to calculate the pressure at the specific location, we're gonna introduce you the wedges element. Okay, this is the wedge element. It is in a triangular shape. Okay, I think this is too theoretical, right? But what I'm gonna show you is the hands-on approach. Okay, can you see this one? What is this?
Which
Okay, this is the wedge. I try to derive step by step so that you understand. Yeah. Okay, this is considered as a wedge. Okay, the wedge. Okay. Right. Okay, consider this is the wedge. In order to understand the fluid static property in the fluid domain, okay, we're gonna derive the wedge element. Okay, this is we call element. This is the wedge. Okay, in the shape of wedge. Okay, so how to do that? Okay. Okay, let's say this is axis. This is Z axis and this is X axis. Okay. Okay. All right. So we have the wedge. Let's say this is my wedge. Okay. Let me. Okay. All right. This is my wedge. Okay. Okay. Let's see. So that means I just draw 2D only on this side. I hope you can see my my camera. Okay, this is the side I just draw. Okay, this is the Z axis, vertical Z axis and horizontal X axis. Alright, so into the page is Y axis. Okay, so okay, this is the width. Okay, this is represent the Y axis. So in this case, let we label first. Alright, okay, this is, what is this? This we call as the change in Z direction. In this one, the change in X direction. So in this one, the change in,
Y direction.
yes, correct. Because our axis, this is our axis. This is X. Sorry, this is Z, this is Y, and this is
X.
X. Okay, now you understand, yeah? This wedge, right? When we look at this wedge, we have the force acting on the wedge. Remember, the force is acting parallel or perpendicular?
Perpendicular.
Perpendicular.
The force acting perpendicular. So this one we call as a force P in
X
which
axis.
which direction? X direction.
X direction.
And this one force acting in
Z direction.
Z.
Z direction. Do we have another force?
Yes.
Which one?
You can
Acting in
the
Y direction.
yeah
Okay, the force. This is slanting.
on the slanty line. Yeah.
Yes, this is slanting. So we gonna have a normal force. Okay, everyone. We call as a P normal. Alright? This is normal force acting on the slanting. Let's say this is the delta S. Okay. So now you understand, everyone? Before we proceed. Okay. So since this is static, let we use the Newton second law, which is summation of force in x direction is equal to mass times acceleration in x direction. Okay. Do we have the acceleration here due to the static?
No.
No, doctor.
So what is the value of acceleration in x direction?
0.
0.
Okay, cancel. This is 0. That means this is equal to 0. Summation of force in x direction equal to 0 because there is no motion at all. Alright, so what is the force involved? Okay, what is the formula of force with the pressure? The pressure is equal to force over
Area.
Over area.
area. How to get the force? Pressure time
Area.
area. Okay, what is the force acting in the x direction? Can you list the force in the x direction?
Px, and then we have a component of Pn also.
Yes, correct. But P is the pressure. How to convert to the force?
Multiply with the area
Area of
of
what?
the x direction facing the face of the x direction.
Yes, correct. So this is my wedge. Okay. What is the okay? This is the px. Okay. What is the area? This is area. Okay. So how to get this area? How to get this area?
Width times height.
It's
Del C into
time.
del X. Sorry, del C into del Y.
Del. Okay. What
Del
is the height? What is the height here?
Del
Del
C.
Z.
Delta z multiply with
Delta Y.
Del Y.
delta y. So px multiply with delta z delta y. Okay, now you understand, yeah? Okay, the next is the pressure Pn because Pn is slanting. How to get the force in the Pn? Okay, let's say this is Pn. This is Pn in x direction. This is Pn in y direction. How to get Pn? Okay, let's say we have the angle. How to get this Pn? Okay, this angle refer to which part? This one or this one? First or second?
Second. Oh, first. Second.
First or second?
Second. Because we're
Who vote for the first? Who vote for the second? Please comment there.
First.
Okay, are you sure? So many
Second.
put. Okay, let's check the answer. Okay, this is my axis. Okay, where this is the Pn. Pn is slanting this way. Okay. This is Pn. Alright. So this is the theta. This is slanting this way. Alright. So this is theta. This is not theta. This is theta. Okay, everyone? Are you get it?
Yes.
Okay, this is theta. It is alternate, yeah? This is theta, this is not theta, this is theta because this is 90 degree. Okay? Alright. So, this is theta. Is this the same theta here?
Yes.
So, which one? The first or the second?
Uh,
The first. Okay, everyone. Now you understand where to place the theta.
Yes, Doctor.
Okay, so now you understand how to place the theta. The theta is here, not here, because we can see from this quadrant. This is theta, not theta. This is theta. So this is alternate angle. Theta will be the same. Alright? Okay, how to get the P of X? Pn of X. So, Pn of X is acting to the left. So it is minus Pn. So this is cos or sine?
Sine.
Yes,
Sine.
perfect. Sine theta. What is the area? What is the area of this?
Delta S times
Delta
S.
delta S multiply with
Delta Y.
delta Y. Okay, this is the area. Delta S multiply with delta Y. You're gonna get this area. Okay, do you have any other force?
No, Doctor.
No, equal to?
Equal to 0.
Okay. So now let's access for the summation of force in Z direction equal to M equal to A MA. Since there is no motion in the Z direction, it is equal to 0. So this is equal to 0. Alright. So what is the force acting in the Z direction? Ibrahim, can you adjust your sounds there? Okay. What is the force acting in the Z direction?
PZ.
Okay, PZ is positive or negative?
Positive.
Positive. PZ multiply with area because this is the force. What is the area of perpendicular to the PZ?
delta X times delta Y.
Delta X.
Delta X multiply with delta
Y.
Y. Okay, good. Okay, another force?
Pn.
Okay, positive or negative?
Negative. Pny.
Negative.
Negative. Because it is acting to the okay, it is acting negative direction. Okay, so Pn cos or sine?
Cos.
Cos.
Cos. If we get the cos, it's going to have Py. So cos theta. So what is the area? The same here. Delta S,
Delta Y.
delta Y. Do we have any other force?
No.
No, Doctor.
Are you sure?
Wait.
Maybe the weight.
Is it? No.
Yes, we have the
Weight.
weight. So this is having the mass. Definitely gonna have the weight. So we have the weight here. Sorry. This is the week. Okay. What is the week? What is the formula of the week? Mass multiply with
G.
gravity. Okay, can you expand the mass? We don't use the mass. We use the density and the volume. So what is the formula of mass? What is the formula of mass, density, and volume? This is density equal to mass over volume. How to get the
Rho V.
mass?
Rho V.
Mass
Density
equal
times
to
volume.
rho V.
V.
Alright. So what we can say here is rho V G.
G.
Okay. So from here, it is minus or positive?
Minus.
Minus. Okay. Let's start with this rho. Okay, volume. How to get this volume? Volume of this wedge.
Change in X into change in Y into change in Z.
Okay, is it like that, or we have another term? Because this is triangle, not the square.
The triangle, the area of triangle times by delta Y.
Okay, how to get the area of triangle?
1 over 2
1
delta
over
x
2.
delta z.
Yes. Yes.
1/2 base times height.
Yes, 1 over 2. Okay. Multiply with delta x, delta y, and delta z.
Z.
Okay, and then we continue with gravity. Okay, do we have any other forces?
No.
No. Equal to 0. Okay. So, let's say this is equation 1. This is equation 2. Alright. So, we can have the relationships of delta z. Okay. Delta z. How to get delta z relation with the slanting? Okay, this is slanting. In order to get delta z, this slanting, delta s, is it cos or sine with theta?
Sine.
Okay, this is in order to get this, delta s, you sine or you cos with this theta in order to get this. This is hypotenuse trigonometry.
Sine.
Sine. Theta. And then delta x is cos theta. Okay. Can you substitute back to the equation number 1 and 2? Okay. Can you substitute? I try to substitute here. Okay. Substitute into equation 1 and 2. Okay. So I try to substitute px, okay. Px, delta z I replace with this one. Delta s sine theta, delta y, and this one minus pn sine theta delta s delta y equal to 0. Can I simplify further? Everyone?
Yes.
Yes.
Okay, which one I should eliminate?
Sine.
Okay, sine, another one?
Delta y.
Delta y.
Delta y,
And delta s.
Delta S.
Delta
S. So we can say that P x is equal to
En.
Pn. Okay, so we can say that the pressure throughout the whole horizontal the same. Are you agree with that? In the horizontal direction, the same pressure acting.
Yes.
Okay, this is swimming pool. This pressure and this pressure the same in the horizontal direction. Do you think this is logic or this is the different? Okay, the pressure in the horizontal direction is the same. Okay, with the same elevation. So this is the proof. Okay, so how about the pressure in the y direction? Sorry, pressure in the z direction, elevation. So how to do that? Let's we substitute. Okay, this is in terms of equation 2. Okay, Pz, Pz delta x, this is delta x, we replace with this one, delta s cos theta delta y. And then minus Pn cos, okay, cos theta delta s delta y minus rho half delta x. Delta x is here. Cos theta delta y delta z g equal to 0. Okay, let's try to eliminate. Okay, cos. Another one?
Delta S
Delta
and delta
S.
Y.
Delta
Delta Y.
delta s, delta y. Delta s, delta y. Delta s, delta y. Okay, so what we have here? Pz minus Pn minus
Rho by 2.
rho by 2 z g equal to 0. So we try to move this to the other side. So Pz is equal to Pn plus half over 2 rho g delta z. So what we can say here, the pressure in the the pressure in the x z direction, is it the same or different from here?
Different, doctor.
Okay,
Different.
It's different.
the pressure in the z direction depends on
The normal pressure.
Depends on
density
elevation.
and the gravity.
normal pressure, and then with the
Wait.
Elevation.
elevation. Okay,
Elevation.
density, the gravity is constant lah. Alright, so it depends mostly on the normal pressure with the density of the water as well as with the elevation. So that is why when this is the comparison, okay, this is the sea water. When someone snorkeling compared to the someone scuba diving, what do you think of the pressure? Which is higher, the snorkeling or the scuba diving?
Diving.
Scuba diving.
Okay, why scuba diving? Can you explain in terms of this equation?
Because
Elevation.
the difference in elevation.
Yes, because of the difference in delta z elevation. The more the value of delta z, it will increase the pressure at z
Z.
direction. Okay, this is Pz. This is Pz. Okay, so far you understand what is the Pz, what is the Px.
Yes,
Yes,
doctor.
Yes, doctor.
Okay, I think that's all for today class. It is very simple, right? I
Yes,
I really hope that you understand the concept of these wages. Okay, because if I explain this, it's very difficult for you to understand, right?
right.
Okay, so by explaining to you the concept of wages step by step, now you understand that the pressure in the x direction is the same. However, for the pressure in the z direction is different. It depends on the elevation. It depends on the
Density.
density.
Normal.
Can you see the density? The more the density of the seawater, the scuba diver will exert more pressure because there is more of the fluid particle on top of this scuba
Diver.
diver. Okay, and then with the normal force and normal pressure. Okay, because why we have normal pressure? Because this fluid particle acting pressure to the scuba diver, PN. Okay?
Yes.
Okay. Okay.
Okay, I think that's all for today class. I hope that you enjoy and understand the concepts of the fluid static by understand the wages element. Okay, so do you guys have take the attendance?
Yes, doctor.
Okay, okay, I will share you the recorded video today in the e-learning. So tomorrow we have another class and as well as the day after tomorrow. So do you have any questions so far before I end the class?
No.
No, yeah? So,
No question, doctor.
okay, I think that's all. See you tomorrow. I end my session with Assalamualaikum warahmatullahi wabarakatuh.
Salam, doctor.
Thank you very much.
Okay,
Thank you, doctor. Assalamualaikum.
welcome.